For about a quarter of a century, the story of our universe seemed pretty settled. We thought we knew the plot, a runaway expansion, driven by a mysterious force, all heading toward a cold, predictable end. But what if that story is wrong? What if the universe itself is changing its mind?
Yeah, you heard that right. That's not me saying it. That's a direct quote from Mustafa Ishak Bushaki, a cosmologist right in the thick of this. The latest data we're getting isn't just a little adjustment. It has the potential to completely rewrite everything we thought we knew about the past, the present, and the ultimate fate of our cosmos.
So that's really the heart of what we're talking about today. The story of dark energy, something we thought was a closed book, might be completely wrong. This comfortable certainty we've had is suddenly being shaken to its core. Let's dig into how we got here and where this might be taking us. All right, so before we get to the bombshell, we got to do a little groundwork. To really get why the new data is so explosive, you first have to understand the theory it's challenging, the story that's been the bedrock of cosmology for decades. Let's talk about the recipe for the universe. It's kind of wild. Look at this chart. Everything you and I know, stars, planets, us, all of it, that's just a tiny 5% sliver. The rest? It's a complete mystery. About 27% is what we call dark matter, the invisible glue holding galaxies together. And a whopping 68% is dark energy, this mysterious force that's actively pushing the universe apart. This brings us to the reigning champ of cosmology, the lambda CDM model. Now, that lambda is the really important part here. It represents the cosmological constant, which is a fancy way of saying dark energy is just a built-in feature of space itself. The idea is that as space expands, you get more space, and therefore more of this anti-gravity energy. It's constant, unchanging.
And this whole idea has such a cool backstory. Einstein actually came up with it way back in 1917, but to make the universe stand still. When Edwin Hubble proved the universe was expanding, Einstein famously called the constant his greatest blunder. But, plot twist, fast forward to 1998, when astronomers discovered the expansion wasn't just happening, it was speeding up. And suddenly, Einstein's blunder looked like a stroke of genius.
So, for 25 years, that was the story. Lambda was king, dark energy was constant, and that was that. But now we have new eyes on the cosmos, and they're painting a much more detailed picture. And in that picture, there's a serious twist in the tale.
And those new eyes belong to this thing, DESI, the Dark Energy Spectroscopic Instrument. And folks, this is not just some telescope. We're talking about a massive project. Almost 1,000 scientists with 5,000 little robotic eyes all staring into the deep universe from a mountaintop in Arizona. It's a cosmic cartographer on a scale we've never seen before.
So what has this beast of an instrument done? Oh, not much. Just created the biggest 3D map of the universe ever. We're talking nearly 15 million galaxies across 11 billion years of cosmic history. And the way it does this is just brilliant. It uses something called baryon acoustic oscillations. You can think of them as fossil sound waves from the baby universe, as a kind of cosmic ruler to measure distances. By seeing how much that cosmic ruler has stretched over billions of years, DESI can rewind the history of cosmic expansion with insane precision. So, the billion-dollar question is, when they put their map together with all the other data, what did they find? This, 4.2 sigma. Now, that might just look like a number, but in the world of physics, oh boy, that number makes your hair stand on end. It's a signal. So, what is 4.2 sigma? It means the odds of this result being a total fluke, just random noise in the data, are about 1 in 30,000. To put that into perspective, that's like flipping a coin 15 times and getting heads every single time. It's not the 5 sigma gold standard for discovery just yet, but it's a very, very strong hint that something real is going on. Okay, so why does this matter to anyone who isn't a cosmologist? Because this isn't just about abstract numbers. The nature of dark energy literally decides the ultimate fate of, well, everything. And if it's changing, the ending we all thought was written in stone is suddenly up for grabs.
See, the standard story ended with something called the Big Freeze. The universe just keeps expanding and accelerating until everything is cold, dark, and lonely. A pretty bleak ending. But if dark energy can change, that ending is no longer a given. Suddenly, there are other possibilities on the table.
And here are the main contenders for how it all ends. You've got the Big Freeze.
if dark energy is constant, like we thought. But if dark energy gets stronger over time, you get the big rip, where it literally tears atoms apart. And if it's weakening, which this new data hints at, we could be looking at a big crunch, where gravity eventually wins and everything collapses back in on itself. No big deal. So we've got this really juicy evidence, and the stakes couldn't be higher. But here's where it gets really interesting, because this isn't a settled story. We are watching the scientific process play out in real time, and there's a huge debate brewing about what this all means.
Okay, here's one of the big wrinkles. The simplest way to look at the data suggests that dark energy actually got stronger for a while before it started weakening. Theorists have a name for this, phantom behavior, and frankly, they don't like it. It just feels unnatural. It seems to break some pretty fundamental rules of physics. This brings us to the core of the debate right now. Is this weird phantom behavior real, or is it just a ghost in the machine, an artifact of the simple math we're using to interpret things? A lot of scientists are pushing for a more physically grounded idea, something called thawing quintessence. This model suggests dark energy is a field that has just been getting weaker the whole time. No weird phantom stuff needed.
And you don't have to take my word for it. Here's a quote from a recent paper by physicists Dinda and Martins. They basically argue that this whole phantom crossing thing is just an artifact of a mathematical shortcut, not something that's actually required by the DSI data itself. It's a modeling problem, they argue, not a universe problem.
And this has just blown the doors wide open for new ideas. Theorists are running wild with possibilities now. Maybe it is thawing quintessence. Or maybe it's a brand new, ridiculously lightweight particle called an axion. Or, and this is the big one, maybe, just maybe, Einstein's theory of gravity isn't the whole story on these massive cosmic scales.
So, where does that leave us? We are at an absolutely thrilling crossroads in cosmology. Is this just a statistical glitch in the data that'll go away when we look closer? Or are we seeing the very first hint of a new force of nature? A dynamic force that's actively changing the fate of our universe as we speak. DESI is still out there, its robotic eyes are still watching, and honestly, what it finds next could change everything.